This question is from the B1 thermal energy transfer, and in which we will compare the intensity wavelength graphs of the two planets X and Y. And one thing that is important mentioned here, that the planet X has a surface temperature that is less than the temperature Y. That's for this reason I have supposed that the planet X must be smaller in size. That's why its temperature is less. So when if its temperature is less and the graph for planet X is shown the dotted, right? So it means that you see that like in all of the options, the dotted graph is representing the graph for the planet X. So we have to select which one of them is right answer. So okay, so if the temperature of X is less than temperature of Y, conceptually it means that in fact both planets are radiating all the energy because we are considering them as a black bodies, and secondly both of the planets are radiating all the electromagnetic spectrum from gamma rays to radio waves. But one thing important to note here, that we know according to Wien's law that the peak wavelength times temperature must be constant. Okay, it means that the peak wavelength is inversely proportional to temperature. In other words, all of the both planets are radiating all the lights, but the light that contains maximum energy and maximum intensity is different for these two planets. Okay, I explain you. Okay, students, so as the planet Y has a more temperature, that's why I am assuming that it is radiating this light which has a maximum energy. So lambda p, for like which we call peak wavelength for the planet Y, is actually the wavelength of the blue light. Okay. Okay, students, so if I show you the graph, okay, graph for the Y, so your idea must be clear that this maximum intensity, which light is actually this wavelength, is peak wavelength is actually the wavelength of this blue light, okay, for the planet Y. And as the planet X has a less temperature, that's why it will radiate less energy than planet Y. And if it is radiating less energy, then it means that it will radiate longer wavelength. Okay, so that's why I'm assuming that the green is a light which carries the maximum energy. So as I told you that it will radiate less energy, it means its curve should be comparably flat. Okay, so lambda x must be more than lambda y. Why? Because the temperature of x is less than temperature of y. According to Wien's law, both are inversely proportional. And last but not least, if I show you the area, this area always shows that how much energy is radiated from the planet. So you see that the area for the planet Y is more under the curve, which means that it is radiating more light. So that's why, first of all, the this is only the right answer, because you see that this is the lambda y and this is the lambda x. So that's why D is the only possible answer. I hope you understand this solution.